The Bluetooth device is ready to pair.
Hello, everybody. Hello, hello, hello. All over the world, parts of the world, Philippines, world. And coming back. I am a singer, eternal voice, YouTube content creator, and social media influencer. Welcome to my science world. Okay, let's erase first the writings on the board. Oh my gosh, what's this? Okay. I slept too much. And by then I will just sleep again after this. Oh my gosh. Okay, so we to discuss, right? So our topic for today, we have done in the linear and angular momentum. Our topic for today, mga palangga ko, is the buoyancy force. Okay? We should consume all the types of forces. Okay? So we have here buoyancy force. Okay? And this is by Archimedes principle. Okay? Mr. Archimedes discovered this principle. Okay? So this is gonna be the reason that the ship will float into the sea. Okay, the coin, when you throw coin to the sea, it will go to the bottom of the sea, and you will just wonder why. Well, the coin will go down, okay, and then the sea will, the ship and the boat will float. Things like this. Since we know that the ship and the boat are having a heavy object compared to a coin, right? You know what means a coin really is? Just like this. Okay, coin. A money that is made of metallic material, round in shape is one coin. So if you try to put this in the sea, on the lake, this will go down. Okay? But the ship, the boat will not go down, it will float. At the point, and also the human being will float. Okay? So this is going to be, apart from the gravity, the force that is responsible well as the buoyant force. Okay, or buoyancy. Get the point? This is talking more about the weight of the fluid displaced by an object, shall we say, partially or wholly meaning entire, immersed or submerged into the surface of the water, or shall we say, a river, a stream, a sea, ocean, lake, like that, or a creek, a small type of river is a creek, right? C-R-E-E-K. All types of surface body of water, if you try to let an object float, it will float. Of course, it depends on the forces, the mass, and the weight. But what I'm trying to emphasize, we have the buoyancy force. Okay? The divers indulge and engage too much buoyant force in order to go deep the bottom of the sea surface. Okay, the divers, something like that. Okay, what else? Yeah, swimming also involves buoyancy force. If you swim, then you will float into the swimming pool, body of water. Then the buoyant force are responsible for that. Apart from the gravity, you get the point. The gravity will always be there. 9.81 meter per second squared, or 32.2 feet per second squared. It depends, it's English unit, you will use 32.2, and if it is SI or metric system unit, you will be able to use 9.81 meter per second squared. That's our standard in the acceleration due to gravity. When you mean of the gravity, that's automatically the G, acceleration due to gravity. Okay? Meaning gravity is also equal to acceleration due to gravity. Okay? Or gravitational force. It's just, the same connotation, or meaning to say the ideology of the gravity thing is just the same. Okay? Now, we need to derive an equation of this buoyancy force through Archimedes principle. Okay, Mr. Archimedes is the person or scientist discovered this principle or theory. That's why it became Archimedes principle. Okay? Something like that. It's gonna be like that. No? So, if I will introduce to you the direct formula, we can have also. But since this is an introductory explanation, I have to discuss the derivation of the equation. Okay, something like that. Okay? So, let's derive the equation so that we can understand. Okay, so we engineers, to those who can relate also, especially if we try to discover the, for example, if we need to install a firefighting line at the top, and then we need to tap the AP. We need to tap a fire hose going to the top, and then we have the specifications of the pressure rating of the hose, something like that. For example, 2-bar hose with a diameter of 2 inches. Okay, and then you need to compute what height will this water will go to the top, in the 7th floor, 6th floor, 5th floor, 4th floor, 3rd floor. And then you can use the formula of the density with relation to the height, to the acceleration due to gravity, or to the pressure. Okay, if you don't have an idea, you cannot do that. You need to calculate. You need to follow the basic formula of one of the term of the Bernoulli equation. The Bernoulli have so many terms, right? There's an algebraic expression. Algebraic expression meaning linear, not exponential, right? So the first term will be the, wait, I have to remember. Hydraulic pressure, and then we have also the kinetic energy, and then the potential energy. Yup, it's gonna be like that, yes, and then equal to 0. And you have to multiply that all with density, something like that. And throughout the equation, if that is not present there, you have to cancel that equal to 0. That's why what will be left will be the term, so that you can compute density. For example, we go back to, before touching this one, because this is very related. Okay, for example, calculate the height of the building that this hose 2-bar will reach the water there to the top, just like an imagination problem, something like this. So you can compute for the pressure, for the height, for that. Okay, so let's go back to pressure. This is the Pascal's law. You know, Pascal discovered the 101,325 Pascal is equal to 1 atmosphere, something like that, or 1.013 bar, or 762, something like that, or 40.7 pound per inch, something like that. Those are the standard values of the pressures, okay, and atmospheric pressure. Okay, so if you have 101,325 Pascal, that is equal to 1 Newton per square meter. Okay, so pressure is equal to force over area. Okay, force is Newton, area is square meter. So 1 Newton per square meter is also equal to 101,325 Pascal. Okay, 14.7 PSI. Okay, 1.013 bar. 760 torr, and also 760 mmHg. Of all these units mentioned here, and I wrote here, the most obvious that we can get directly the height is in terms of mmHg, because there's a millimeters in the unit. So it's very easy to manipulate how to compute the height, because the millimeter is very obvious. Okay, like that. But in the other units of pressure, there's no millimeter, there's no meter involved, except for the Pascal. Okay? And the PSI also. You convert inches to meter, blah, blah, blah. Because we have 1 Newton meter is equal to 101.325 Pascal, then you can compute the area, okay, the force, the height, blah, 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 blah. Okay, how can you do this? Okay. For example, if I have here the sea, okay, the sea, and for example, this is the, let's say, a concrete platform, and Junjun stand in the concrete platform, me, myself, okay, I'm standing here, and I'm gonna be able to, let's say, throw, let's say, an aluminum, this is only for the purpose of discussion, a square in shape aluminum material, something like here, okay, so, like that. So this aluminum material will exert the velocity, the acceleration, like that, the momentum, the impulse, the density, the force, the pressure, the volume, the surface area, like that, name it, the surface tension, okay, the specific gravity, the acceleration due to gravity, the gravitational force as well. So many quantities in science will be applied here by just throwing one material to the sea. Okay? You can create so many equations in your brain cells when you throw something in the sea. That is if you are really highly scientific and you love science, right? But if you don't care about science, you don't have to love this academic subject, then you are not interested for these quantities, right? You just ignore as if nothing happens, something like that. But if you are really scientific and you love science that much, then so many quantities will be involved with just throwing or dropping the metallic material to the sea. On. Then Junjun drop this to the sea, okay, for example. Then this, for the purpose of discussion, we have the weight of the aluminum material. Okay, the weight will be here going downward, okay, like that. So this is the weight. The formula of the weight is mass times acceleration due to gravity because this is vertical, okay? Vertical is acceleration due to gravity is applicable to vertical motion, not horizontal. The acceleration will be used in horizontal are the A, the acceleration, the instantaneous acceleration, the average acceleration, the plus so and so, and the total acceleration, things like this. But here it is downward, then you have the acceleration due to gravity exclusive. Nothing. Okay? Acceleration due to gravity, G. So 9.81 meter per second square or 32.2 feet per second square. Okay. So if you cannot memorize these standards, then you are not finishing your physics because these are the very common standards in physics, the acceleration due to gravity. Okay, something like that. Now, so if you will put, say, let's say for example, oh my gosh, for the purpose of discussion, mga palangga, umitad, charot. Okay, so for the purpose of discussion, I'll need to louder my voice, right? Because my microphone is low but again. Okay, so for example, if I'll try this to tie with a string, something like that, there's a tension, right? Tension is going upward like that. And then bottom, so you will say summation of net force is equal to the tension positive because up and minus the weight going down, something like this. Tension is equals to the mass and acceleration due to gravity. This is your first equation. Okay, now say for example I don't put the rope to tie with this metallic material, so I don't have T. So I will just have to tell that this gonna be having a force. Okay, so you will say the force is gonna be a force, okay, like that is equal to minus weight. Okay, like that. So you will say force is equals to weight. Right? So therefore you can say force also is equals to mass times acceleration due to gravity. Okay, this we are referring here, the force here, okay, this will be the buoyant force as this object will reach to the sea. There will be an upward force. Okay, of course when you drop the metallic material, it will touch to the surface of the water. Either be floating, sinking, partially immersed, something like that, or totally sinking at the bottom of the surface. So there are three, situations: floating, sinking totally, and partially floating, partially sinking. Okay, like that. Now, since this is upward force here, you'll be able to have F going to the top. That's why you say positive force minus weight going down. So if a total net force will be equal to 0 at equilibrium at the natural process, then we will say force is equals to weight. Since the formula of weight is equals to mass acceleration due to gravity, then force is equals to mass times acceleration due to gravity. So this is now your buoyant force. The force, upward force or up thrust, meaning UPT at HRUST, meaning thrust, a push to a certain object so that it will be moving. That is a thrust in English. T-H-R-U-S-T. This is a little bit a deep term if you are familiar in the journalism, or if you're a writer, an editor, a member of technical report writing in your school, or are one of the editors of your school, then these terms are a little bit deeper. Okay, thrust meaning push, T-H-R-U-S-T. So meaning an up thrust, up because it's going up, and then add push, thrust. So up thrust and upward force, okay? This force, right, that is trying to oppose the weight of this metallic material, okay, that is being wholly submerged, partially submerged, or immersed, something like that, and then the weight displaced, oppose the weight displaced of an object. Okay, ganon. So, emerge, submerge, and immersed is just the same meaning in English. If you try to submerge, immersed, sink, like that, these are the same meaning. Okay? That's why we have a submarine, something like that, submerging into the bottom part of the sea. None. Okay? So it's gonna be like that. So this upward or upthrust force, which is the buoyant force, will oppose the weight of the fluid displaced by the metallic object pushes the sea surface, like that, whether it is wholly or partially immersed into water. Okay, what will immerse to the water and what will submerge to the water is the object. Okay, so that is buoyant force or buoyancy force. So at least you will know already what's the definition of buoyancy force, right? It's never going downward, it's always upward. Just like this is the equivalent notion, or let's say a connotation, or an ideology, or an understanding or concept regarding the normal force. Okay, so normal force is involved in the surface wherein there's no water, right? Only the floor, or the blah blah blah, so and so. But if there's water, the normal force will be now your buoyant force. So meaning to say, buoyant force is exclusive to have fluid, okay, liquid, okay, and gas, but never to solid. Okay, because how can you emerge the object to a solid? It will never float, right? Common sense. So the force there equivalent to buoyant force is the normal force. Okay? You get the point? Things like that. And that is the definition. I don't have to write, right? Because it will be reflected in your brain cells as I talk the definition of buoyant force, right? Or I have to write. I have to write to make it clear. Something like that. Okay? So class, I have to write the definition of a buoyant force. Okay? Or buoyancy force. This is very lively because we experience this in our real life. When we go to the beach, when we swim, there's a buoyant force. When we swim, when somebody floats, when an object floats, there's a buoyant force. Meaning, this is really a practical understanding of the topic of the buoyant force in our daily lives. Okay, not only limited to the sea, to the ocean, to the lake, but also to the river, to the creeks, whatever. Any surfaces of body water in the planet Earth have buoyancy force. If you try to drop, if you try to throw certain objects into it, aside from the gravity, there will be a buoyant force. Okay? Get the point. Ganon. So buoyant force, we'll say BF. This is not boyfriend, but buoyant force. Okay? Because you will say, what's BF, Sotero? Because acronym will have so many meaning, but to get straight with the topic, this is buoyant force. That not boyfriend. Okay? Buoyant force, BF. Okay? It's an upward force. Okay? Okay, that opposes meaning resist, or in opposite direction to the movement, either going downward or going upward, as long as it is opposing, okay, or resisting the forces going down, going up, going to the left, going to the, anything will oppose. Okay, that is opposing, okay, like that, or resist. Okay, get the point. Upward force that will try to oppose, that opposes, I mean, you can also use the word resist. It depends on the situation. That opposes the weight displaced. The weight of, you should mention, the weight of the lake, ocean, river, like that. The weight of the, to make it general, the weight of the fluid na lang siya, or liquid displaced. Okay? By the object submerged or immersed into the fluid. Okay? Into the fluid, something like that. But this immersion and submersion of object can either be partially, wholly, meaning the entire will be sinking. So that's coverage of buoyancy also. Okay, because even though it's floating, it's partially sinking, it's partially floating, and then sinking all throughout, buoyant force will be applied. Okay, now, this is the time to introduce to you the 3 types of buoyant forces. Okay, take down in your blank sheet of paper so that you can remember this if you are trying to take an examination in the future, physics examination, or you have physics subject to take, and this is the theory. 3 types of buoyant force, 3 types of BF. Okay, so like this. Okay, we have the neutral buoyant force. Okay, it's very easy to memorize. Put this in your brain cells. Okay, positive buoyant force. Okay, and the negative buoyant force. You have to learn those terminologies because the problems will say, what is the negative buoyant force if Sotero will be sinking in the swimming pool? Oh, ganon. Since I know my weight, I have 64 kilograms, then I know the acceleration due to gravity, then bingo, I can solve for the buoyant force, even though the data is not mentioned in the problem. Right? That was so amazing. There's no data, but you can solve what is being asked. Calculate the buoyant force of Junjun when Junjun swim in the swimming pool. Ganon lang siya kasimple ang problem. Okay? Then you can compute immediately without question. Okay. Now, you will identify if it is neutral, positive, negative. Now, if I will totally be sinking, I will use the negative buoyant force. Now, if I am only floating, I will use the positive buoyant force. Now, if I am either floating, either sinking halfway, partial, 50-50, chuba-chuchu, my body is a little bit sinking, and I am also a little bit floating. So I will use the neutral buoyant force. So you will take note how the problem will be phrased in the certain question, because your answer also will matter, something like that. Because the point, ganon. So these are the 3 types of buoyant forces. Okay. Now, since I tell you that the formula of the buoyant force is equal to the weight times acceleration due to gravity, that is only the plain buoyant force. And as I promised a while ago, I have to derive the equation in which this is the detailed buoyant force to be used in engineering purpose or any in BS math profession. BS math also are very good in mathematics. BS math professionals. Same also with engineering professionals. Math will be our, our kinaon, something like that. And also the data scientists are good also in math. Okay? Like that. Data scientists will be more on the sampling of the surveys, the census of the population, on the community. That's data scientists. Okay? And then, okay, we have also the BS math and the engineering and the engineers. Okay? It's gonna be 3 only that have rigid mathematics. Okay, meaning detailed. Okay? You get the point? So we need to derive. Okay? So that we can understand. Now, for example, mga palangga, I will be able to have my glass here. Let's do the practical application. I have the glass here. Oh my gosh, very dirty. There's a soya liquid. Okay, this is the transparent glass here. Hello, mga palangga. This is your science instructor, Engineer Sotero and Nepomuceno Jr. This is actual demonstration of a buoyant force derivation of equation. Now, if I have this glass, I will pour water. Okay, I will pour water. Okay? Something like that. Oh my gosh. Okay, wait for a while, mga palangga, ha? Okay, so let's do the actual experimentation or demonstration. Water is life. Charot. Shh. Okay, this is water. Hello, mga palangga. This is water. Then I need to drop, let's say, a square object because we need to use the geometric shape that is perfect because it's not easy to measure the irregular shape object that I will try to submerge in the water, in the glass of water. So I need to establish the perfect shape so that I can calculate the surface area, the volume of the square, the area of the, the circle, something like that. So let's say I will drop the, tepasa guys. Kanilang, okay, so this is a rectangular, right? This and I will drop this. Let's imagine to the highest level. But I will not drop this, I have to drink this. Okay, I need to save money. Okay, only understand, okay? If I will drop this rectangular shape, going to the glass, okay, let's say, nato na siya dito ako sa nainyon. Ako lang i-show, okay? Because this is drinking water. Okay? Sayang. Okay? Okay, now, I need to draw now, based on our imagination here. There is my glass here. Okay, I poured water here. Water. And then there's a rectangular submersion in the center of the fluid. Okay? Like this. Fluid we consider here is actually water specifically. Okay, fluid is general. It could be either an oil, an organic solvents, an acetone, an alcohol, something like that. And then water is the most common. Okay? So let's go to the most common with this water. Okay, something like that. Now this is rectangular, right? Okay. So we have the length and the width. Okay, the length and the width of the rectangle. So we'll say length and the width. Okay, something like that. For the derivation purpose, we need to make it a parallel so that we can, we can easily cancel somewhere out the way based on our equation. So we can just simply say our L is our D length, and our W is our D length also. But anyway, that is only a measure of the dimension is just the same for the purpose of derivation. Okay, now, so here when you submerge the rectangular object, which is this a while ago, right? I have to say, there is forces exerted here. Okay, forces going downward, forces going upward, like that. There's a pressure also going downward, like a pressure. And there's also pressure going upward, like that. Okay, so you could imagine, oh my gosh, so many pressure, so many forces involved. Not only that, the velocities. Okay, velocity of the object material for this one that I know. Okay, and the mass of this, the mass of that rectangular chuba-chucho. Let's say, M lang siya because I don't have to measure this one because I cannot measure this also because it is not a defined mass. Meaning, I cannot compute because I don't have the device to measure. Okay? Like that. So let's just put this as a mass only, generally M, small m. Okay, ganon. Okay, now, what will be happening here? So you have the pressure going to the down PB, right? And you have the pressure going to the something like that. And now, you need to add all forces here. The same with the theory of forces also in the FBD diagram related to solid surfaces, something like it's just the same story. You need to add all the forces. That is a net force, like that also. Same story here. The difference is there's a water and there's a gravity, something like that. You don't have there's an acceleration due to gravity, something like that. Because horizontal, no acceleration due to gravity. And okay, and the gravity will not work on it. Okay, if horizontal. This is vertical na siya, motion. Or so you need to consider the acceleration due to gravity and the gravity itself. What I mean of gravity itself? Gravitational force. Okay? Ganon. So I will say, force that going up. I already discussed that a while ago. That is the definition of the buoyant force. So that is FB. And then we have also the F going down. That is FD. Something like that. Okay? Now, since we are interested here with the pressures, we go to the pressures summation, not for the, total net force. By the way, we can correlate that also later on, okay? So you will say F net, okay, the F net or the net force is equal to the forces that will go up, which is the buoyant force, positive because it's go up. So FB, okay, this is not Facebook, this is buoyant force. Okay, FB here is not Facebook, this is buoyant force. Okay, buoyant force, okay, and then this FD will be subtraction because this is going down. The force is going down, right? So minus FD. Okay, since this is in terms of force, we can convert this into in terms of our pressure. Okay, because pressure is very, very useful in this kind of problem in the buoyant forces for the purpose that we can really achieve the desired equation for the buoyant force that involves so many quantities, not only the two, the mg only, chupa-chuchu. Okay, now, so diba, yung ko before, pressure is equal to force over A. So since we have subscript here B and D, we will also say PD is equals to FD over, okay, AD. Okay, since area is common, the two subscripts, so this is just only A, capital A. Okay, like that. And the other one also, B. So PB is equals to FB over A, because A is the common surface area will never change. What will change here are the forces, are the pressure. So we held constant the surface area in this situation. That's why I did not put subscript of the A. So A alone is just equal. Okay, you need to put subscript. Okay, it's gonna be like that now. So F net is equals to FB. So in here you can get the FB, right? Do the math, very easy, cross multiplication. So we have the pressure of the bottom, okay, or the here, like that, okay, times the area, right? Ganon. And then the FD, diri gapon, ano din ka, makuha din mo siya, okay, win ka na, force, PD, PD times area, right? Ganon. This is net force already. Okay, now, we need to break the area as I mentioned a while ago. So this is a rectangular, right? So what is the area of a rectangular? So length times width only. Let's review a little bit in our elementary geometry. So rectangle, length times width. Area of a triangle is 1/2 base times height. Okay. Area of a sphere is 4 pi r squared, right? And then area of a square is sides raised to the power 2, because all the sides of a square is equal. So s raised to the power 2, right? You get the point? Ganon. Okay? And the area of a round or circle is pi r squared. Okay? Pi r squared lang siya in terms of radius, and also pi d squared over 4 in terms of diameter. So these are the basic geometrical shapes, area, basic concept in elementary education, in our grade school education. Now, what applicable here is the rectangle, right? So since I changed this with D to make it parallel with each other, so it's gonna be area of a rectangle. This is rectangle that I dropped in the water, right? It's not round, so it's rectangle. So I say length times width. Our length is D, right? And my width also is D. So D times D. So I have area is equals to D raised to the power 2. So this is our area of our rectangular. So if we have A now, substitute that in your equation here. So you will say pressure B, ganun chuba chuchu, area D raised to the power 2 times PD the A, D raised to the power 2. Ganon. Now, take the individual pressure of here. Okay. Now, in this case, is the case we need to relate the mass of object, the height of the container, the height, positioning, the displacement of the height. Meaning, if the object is still here, it will go to the downside. What is the height displaced? This is the height we mean here, not the stationary height of the container, or not the stationary height also of the rectangle. This one, we have the rectangle, right? There is a height, this one, right? This is not what we refer as h here. Okay? This is the displaced height when it's going downward from the container. Okay? Right? In a fluid flow. Right? So it's gonna, fluid mechanics pala, sorry. Okay? Like that. So F net is equals to this. Okay? Now, I said a while ago, pressure is equals to, okay, force over area. Diba, I told you a while ago that the force is just equal directly to mass times acceleration to gravity. So substitute. So this is also another small derivation. We still also derive another small derivation so that we can substitute that in our big picture derivation of equation. So here, we will derive a little bit. Okay, very easy derivation of pressure. So pressure is equals to force, then force is equal to mass times acceleration due to gravity, right, over area. Pwede mga palangga. So it's gonna be pressure is equals to mass times acceleration due to gravity of the area, because force is equals to mass times g in your vertical motion. Okay, like that. Now, we have the formula of density. Okay, density, mass over volume. Why we need this? Because we have mass incorporation in our derivation. It will match there. It talks about the mass, it talks about the volume here because it's a water. So volume, the mass. So we need to establish an equation that involves masses and volume. That's why we need to arrive the formula of density also. So density is equal to mass over volume. Since the mass is in the numerator, we can solve the mass in terms of our basic equation, which density is equal to mass over volume. Then do the basic math again by cross multiplication. We have mass times 1. Mass. Ganon. Okay, because this is understood to be over 1. Then density times volume. So density times volume. So mass is equal to density times volume. Substitute that in your numerator here. It will become pressure times density times volume times acceleration due to gravity over area. Okay, this is the equation. Pressure is equal to density times the volume, okay, times the acceleration due to gravity over the area. Now take note mga palangga, what will happen here? Let's simplify further. Okay? Ana siya ang mga technique sa mga equation derivation, simplification of variables, ganon, chupa-chuchu, right? Mga palangga. Okay. So, I will rewrite that here. So it's very lengthy, right? Derivation pa lang siya, this is not in the problem solving, okay? So I have here, okay, mga palangga. Okay, density. Be careful, this is very important in engineering, okay? In physics examinations related to science and math, okay? So pressure, if you love science and math also. So pressure is equal to density times the volume times acceleration to gravity over area. Guys, the volume and area, you can relate that one. Okay, what is the formula of a volume? And area also, what is the formula of area? Okay, now, volume, okay, if we try about volume, guys, in science, we need to focus to the ice cube always. Ice cube, you know ice cube? The perfectly crystalline with lattice energy, frozen ice. There's an ice cube, right? You put that inside your refrigerator and you can obtain a small cube. So we need to refer that kind of geometrical shape to equate our derivation here. And this is standard all over the world that always the cube will be referred because it's perfect. You know, perfect. So volume, length times width times height. The height there is the thickness. Again. Volume of a cube, a perfectly crystalline solid ice in a small cubes. So this is going to be volume, length times width times height actually. The height is automatically, technically equal to the thickness because that is vertical. So you will say length times width and thickness. Since in our purpose of a discussion in physics or any pure sciences, we need to make it general. As I consistently said a while ago, we will just put D as our dimension, right? I could say also volume, distance in length times distance in width times distance in thickness because there are all the measure of dimensions. I would say volume is equal to distance raised to the power 3. That's why we have the formula of volume, S raised to the power 3, X raised to the power 3, D raised to the power 3. Any letter will be used as long as you refer that as the side of the cube. The representation of the letters are not important. You need to understand that is the side or the length of the cube. The thickness, the length, and the width. So we have one letter, right? D. So D times D times D is equal to D raised to the power 3. Oh, ganon. So D raised to the power 3. Substitute that here in your equation. Pressure is equal to density times D raised to the power 3 over, okay, the acceleration due to the gravity times area, mga palangga, kung hitad. Ganon. Okay. Now, area. We have also area in the denominator. We need to simplify that to match with the D letters and the numerator. So area also of a rectangular, because we immerse the rectangular here. Or we will refer also the cube if you want. It doesn't matter. So area of a cube. Oh, ano ba? D length times width lang siya. Okay, so D times D. So this is D raised to the power 2. Substitute the D raised to the power 2 in the denominator. What happens? You have common letters D. So D raised to the power 3 in the numerator and T raised to the power 2 in the denominator. So it's very obvious that we can cancel the D raised to the power 2 in the denominator and the D3 in the up. So what will remain? We have only one D in the equation. So pressure is equal to density times D times G. Now, since we are referring to the vertical, our D, as I told you consistently, is also equal to H. So D is equals to H. That's why in physics, science, we have the formula of density, pressure density times height times acceleration due to gravity. That's why we arrived that pressure formula in science because of this concept. You get the point? Now, in this formula, pressure is equal to density times height times acceleration due to gravity. Based on the introductory part of the discussion, if you have the ratings of your hose, which is the pressure, and the density of water, we have standard, then we can compute the height, the elevation of the building, of the hose of the water it will reach due to its corresponding pressure. So you will say, height of the building is equals to the pressure over the density and the acceleration due to gravity. Acceleration due to gravity is constant. Density of water, which is 1,000 kilogram cubic per meter, or it depends on the unit of the pressure of the hose when you buy the hose. Pressure rating, expressed either bar, I told you so many units of pressure, right? Bar, PSI, Pascal, something like that. Then substitute them here, the bingo, you can compute the height of first floor, second floor, third floor, in which the water of your hose will go. Okay? So you can compute technically for that by having only the specification of the hose you buy in the market. Okay? In this equation, pressure is equal to density times height times G. Coming from pressure is equal to force over area. Okay? And incorporating the value of the force is mass times acceleration due to gravity. You get the point? And also try to link the geometrical shape formulas of volume and area. Then bingo, you can formulate the equation. Even though even though you are not looking on the book, you can create your own equation. Okay? Things like that. All you have to do, you need to understand. Just like me, I told you, I'm not good in math, but I need to understand what's happening so that it will become an attitude, it will become a culture. Then you start loving it. Something like that. So the way we're doing it, and then since that's part of science in engineering, then you love already math as you go in your 5th year college, and then bingo, you will become a licensed engineer in the future. Okay? Ganon. So basic foundations. Okay, you get the point. So tutuwaran pa rin siya, masolve jud mo guys. Okay? You get the point. Only our mind is telling us, difficult, but it's not difficult really. Okay, you get the point. Our mentality. Something like that. So this is gonna be our formula. Pressure is equal to density times height times acceleration due to gravity. But this is still pressure. We go back to our general derivation again. I will erase this. Okay, because there's not enough space. As I told you a while ago, my magnetic vector is very less in dimension. I cannot explain very well because, very limited space. Something. Ow! Okay, that's okay. I will say, ganon. Ano na to, no? So, net force. Net force is equals to ganon, chuba-chuchu. Okay, F, B, D squared. Ganon, di ba? You get the point? Wala pa lang akong hitad. Ganon. And then minus P, going to the down, right? Ganon. And then, down PD, D squared, right? Now, Okay, I have already the value of the pressure, huh? So pressure is equals to density. We will derive already. Okay, density times the height times the acceleration due to gravity. So the way it become pressure, I will tell you. Density is kilogram per cubic meter. Height is meter. And acceleration due to gravity, meter per second squared. Cancel the meter squared. What will be left is the kilogram, okay, per meter squared. Something like that. Again, that's why we need to be consistent. Okay, pressure is equals to the density, right? Density times the height times acceleration due to gravity. Density, kilogram per cubic meter. Height, meter. So you cancel the meter, m squared will be left. And then the other one is meter per second squared. So this is kilogram meter squared. Okay, meter second squared. Then cancel also another m. Okay, so this is gonna be kilogram. Okay, kilogram meter squared, and then the other one is 1 meter squared also. Okay, you get the point. So kilogram per meter squared is the Newton here. This is the value. So 1 Newton is equal to 1 kilogram meter per second squared. Since you now have the kilogram meter per second here, so you will change that. So Newton times 1 over meter squared. Then do the math. Newton times 1, Newton. Ganon. 1 times meter squared, so meter squared. So this is now equal to Newton per square meter, which is a unit of pressure. And this 1 Newton per meter squared is equal to all types of pressure I mentioned a while ago. 760 mmHg, 760 torr, 1.013 bar, 14.7 psi, 1 atmosphere, like 101,325 Pascal. So Pascal is the most popular because this is the definition of Pascal. 1 Pascal is equal to 1 Newton per meter squared. But you can convert this also to another unit. Okay. But some books, guys, or they're using 1 bar only, but actually that is 1.013 bar. 1.013 bar is equal to 1 atmosphere. It's not a perfect 1 bar that is equal to 1 atmosphere. They just do it directly because the 0.013 looks like negligible. Right? It looks like negligible because it's 0.013, so meaning no meaning at all. But when during computation, you need to apply the 0.013 because it matters also a lot. If the choice is having point something, not figure. So 1.013 bar is equals to 1 atmosphere. Is equals to 14.7 psi is equal to 101,325 Pascal. Okay, 101.325 kilopascal, and then 760 mmHg, and 760 torr. These are all the units of pressure. Choose among that and do the conversion factors, and you will be happy. Especially for the design of the equipment, rotating equipment, stationary equipment, whatever, or unit process equipment, all have specifications. They're always in the specification, the marking in the in the pipe. If centrifugal pump, something like that, centrifugal pump, being rotating, something like that, okay? So you can count there the pressure with corresponding with the power in horsepower, unit of electrical energy, right? And the watts, something like that. All motors have that rating, no excuse, okay? Kita pa, anak-anak siya. Okay, now, so we have now the equation, F net is equals to PBD squared minus, so we need to get the common. But before getting the common, what is PB? So this is the pressure. So you're going to say density B times height B times acceleration due to the gravity G. I don't put the subscript because the G is common in this, just like the area. Okay? So minus, ganon. Okay, times D squared here. And then another minus PD, so pressure D is so density D, height D times the G, okay, times D squared. Now in math, you need to observe the commonalities of the terms variables. So what are variables are common here? It's gonna be D raised to the power 2, right? D squared. Now factor out that one. Okay, so you will say D squared times density B height, B, acceleration due to gravity, something like that. And then density D, okay, mga palangga kong hitad, then H, D times acceleration due to gravity. Ganon. Okay. So what will happen here? This is math distribution, multiplication. Distribution. So, distribute. D squared times density B is equal to D squared, chuba chuchu, density B, H, B, G. O, ganon. So, this is gonna be a density squared, density D, H, okay, H, tanawa rin, o, ano na siya, so, D, H, D, density. O, ganon. O, diba? Nakuha na ninyo mga palagakitad. It's gonna be like that. Kaya napaman na siya D dire ari. Okay, ganon. Now, take note mga palangga kung hitad. Okay, there's a common, right? See? Common ang D, ganon. So now, you need to analyze the situation in your volume of water. Okay, in here, as I told you here. Okay, so we have the pressure on the top, right? Okay, okay. The pressure on the bottom is higher than the pressure at the top. Because it is sinking, right? So more of the force and the weight are going downward. So it's expected the pressure at the bottom is higher than the pressure at the top. That's why we said PB minus D. D is on the top, right? So what is the formula? Since we have the rectangle here, ganon. And we have already sinking, right? There's the water here, already sinking throughout na talaga siya. You have also the H here at the top. That's why I told you, the H displacement. We're talking now of the H displacement. So this is the H1 above during initial displacement, so H. And we have also the height of the rectangular, this one, I put this one. This is the D equal to H as I told you consistently. This will become also 2, ganon. This is D, right? Ganon. Oh, H, D, ganon. So, ang atong pressure nga ng higayuna, muana na yung sa height niya dari ari nga H plus D here situation. And this is on the top. So, it's gonna be here. Okay? You get the point? It's gonna be here. So, in here, we need still incorporate the D. Not only the H. So, it's gonna be like this. Rearrange D squared PB, HB, acceleration gravity, then D squared, they're gonna chupa-chucho, this one. So this is gonna be density D, H plus D times the acceleration due to gravity. Ganon. Right? Mga palangga kong hitad. So it's gonna be like that. So D plus H, di ba? This is H plus D. Oh, this is gonna be H plus D. Ganon. O, diba? Muna siyang HD. O. HD is equals to H plus D. The displacement height of this rectangular object sink to the bottom of the glass of the water I showed you a while ago, and the distance of this object. It's gonna be HD is equals to H plus D. Nakakaloka, diba? Okay? So, H plus D. Ganon. Okay, I will say H plus D, ganon. O, diba nakakaloka? Ganon na. O, diba? So, ano na siya mga palangakitad? So, this still have, acceleration due to gravity. Over here. O, ganon. Now, if, sir, so many subscribe, can you simplify that? So many subscribe. Okay? It's up to you. This is only the subscript. It doesn't matter as long as you understand that it's gonna be the bottom, D, the top, gano'n. Anyway, you can put any letters as you want. Di ba? Ganun mga palangga. O, ganun siya. So, D, ganun siya, no? Density D, density D, Pag di ka maglibog, guys, wag yung parentheses. Okay? So, H plus D, ganon. Times acceleration due to gravity times D squared, mga palangga kung hitad. Okay. Now, you have now like this, right? So, D squared is equal to density B, height B, acceleration due to gravity, then distribution multiplication in math. So, this is gonna be D squared, okay, P, D, okay, H, D squared, right? Ganon, and D. Ganon, di ba? So, sa'yo na lang kayo siya, guys. And then, plus d squared, okay, d, ganon nakakaloka, di ba? Times acceleration due to gravity. Ganon! Okay. You get the point, mga palitan. Now, in here, what will be the common here? Again, commonalities. Okay, what is common here is the density, okay, the height, and the d squared. So, this is common, right? The same property. So, this one minus this one will be equal to 0 because it's common to all. Okay? What will left, mga palangga kong hitad, it's gonna be this one. Okay? D squared, okay, ganon siya ba? Okay? Times the density, okay, and the acceleration due to gravity. Okay? D squared, acceleration due to gravity, and then the density. Ganon. O, di ba? Anak na yun siya. You get the point, mga palangga. Muna na siya yung metabo. And then, height pa siya. Because the pressure has height. Right? Napaman siya height dari ari. Okay, ganon. Height na siya. Since height is equal to d, this will become d cubed. Right? So, it's gonna be d cubed. Consistent kayo ko, guys. Height will be equal to d man. So, naman kay height dari nga h. Replace d with it, and d times d squared is equal to d cubed. So, d cubed and density times g. Ganon. So, meron na itong equation, and we need to simplify further. Ganon. Taas kayo, no? Okay, but we need to be patient. Okay, like that. So, we have now F net. Your F net now will be your simply as your buoyant force. F net or buoyant force, FB, okay, is equal to this one, the final equation. D cubed, density times acceleration due to gravity, mga palangga. Okay, take note, mga palangga, kung hitad. Nakakaloka, no, di ba? So, D cubed is also volume. As I told you here a while ago, this is the volume of a cube, right? Blah, 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 so and so. So, this will become V. So, buoyant force is equals to the volume times density times G. This is now the final formula of your buoyant force. Volume times density times acceleration due to gravity. So, this is all about the fluid. Okay, this fluid. And then, the mass also will be based on the density. Mass of the object. Okay, here. Okay? So, pwede mo i-separate. Buoyant force of the object. Buoyant force of the fluid. And then you can do subtraction between so that you can determine the buoyant force displaced. Right? Like that. So, here, object, fluid. You can do manipulation, right? Still the same. Okay? Ana-ana siya. Muna na itong final formula. So, buoyant force equals the volume times density times acceleration due to the gravity. Okay, ganon. Okay. Take note, mga palangga, kung hitad. Tayo. Volume is cubic meter. This is the real unit. Meter, right? For the dimensions. So, cubic meter. Density, kilogram, cubic meter. Cancel cubic meter, this is kilogram also. So, if you try to reduce that further, it will become buoyant force is equals to the mass times acceleration due to gravity. In which, nilugwa na ta sa akong introduction, I told you a while ago, buoyant force is simply equal to mass times acceleration due to gravity. And it's here in the final. Right? But normal problems will not deal with this. Because of mass times acceleration due to gravity. It's more on dealing with the volume and the density. Most of the problems will be given density of the air, density of the fluid. So you will attack by using this equation because this is just the same. So this is the more simplified answer. So in this simplified, this one, you can say, you can derive the definition there. It is, buoyant force is the weight of the fluid displaced by an object. Either it could be sinking, floating, or partially sinking and floating. So you cannot create your definition out of your equation final. So in science, this is called now scientific law. Okay? When we mean of scientific law, this is more on equations, formulas to back up our scientific theory and our principles. So we cannot really prove correct and valid our theory and principles and concepts if our scientific laws will not justify Yeah, that's why we have numbers to prove. Meaning numbers are application in order to justify and to prove that our principles, concepts, and theory are valid, correct, logical, and undebatable. Undebatable, meaning it's not arguable, meaning we agree to one specific theory, meaning factual. Get the point? Not opinionated. That's why it's very good to vlog science because all of us will agree. This highly technical, not opinionated, because opinionated, just like political views, sports, movies, we have so many views in our minds. We are polarized. We don't have the same brain cells. We don't have the same level of intelligence. But that is not true with math and science. We will agree because all are highly technical. Based on scientific laws and equations, we need to prove that our theory, principles, and concepts are really true, correct, valid, logical, and undebatable. Okay? Meaning factual. Any questions so far? That is a very long derivation, right? Okay. Any questions so far? You need to memorize the actual formula because it will be used in our problem solving later on. Any questions so far with this buoyancy force discussion? Okay. Nothing? Nothing ba? Okay. Like that. There's no question anymore? Okay. So, I need to have the problem solving. No, let's cut this for a while and let's go back for the problem solving. Right? Guys, buoyancy force are not complicated. It's very easy to manipulate. It's easy to solve. Compared to the, angular momentum, like that, centripetal force, electrostatic force, electromagnetic force, mga ganon-ganon chupa-chuchu. Di ba nakuha na ito ninyo may ato? Mas lisod ba ito siya, guys? Okay? You get the point? Ganon. Okay? Ganon siya. Okay? What else? Thank you so much for watching for this. Look at my hair. So thank you so much for watching this live streaming about buoyancy force or buoyant force. Thank you so much. God bless everybody. Okay. Thank you so much for watching this derivation of the buoyant force formula. I hope you can understand very well based on my discussion, and you can comment, you can like, you can share, and you can also subscribe my writing channel if you want, and then you can click the notification bell for some newest updates that I am a singer, eternal voice. Bye bye, God bless everybody. See you later. Shwara.